Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by Sana Withers, one of our regular co-hosts and hosts. We together are broadcasting live from the icy and snowy Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. As a reminder, York Universe broadcasts live every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. UT, if that's more your speed. The live broadcast is on YouTube, York U Observatory, in concert with our online public viewing program run by the Observatory team. To navigate to the live show or watch previous recordings or find out more information, you can check out our website at yorku.ca/science/observatory, and you can navigate over to online public viewing or click on any of the YouTube links to take you directly to our YouTube channel. If you're just here for the radio podcast, of course, that's Spotify, Apple, and all other podcast distributors. If you have any questions or comments or actually ideas for future shows, please send us an email at observe@yorku.ca. You can also connect with us on social media over on Instagram at YorkU Observatory, Facebook at Allan I. Carswell Obs, and PixelFed at Allan I. Carswell Observatory. All of our programs are free, but if you'd like to make a donation, please see us at that same website before yorku.ca/science/observatory. Most of our programs are in fact donation run, so any donations are appreciated. Our crew is monitoring the chat room for questions and to post content. And of course, the current weather is always of concern because that will dictate whether or not we're able to show live views on OPV. The weather looks to be pretty darn cloudy and icy over the main telescopes. How's the weather where you are, Sana?
It's more or less about the same. We've had a couple patches of clear sky here and there. It was looking pretty clear earlier, but still pretty grim for observing tonight.
Yeah, it's snow, ice, high wind, high humidity. This is going to be a real challenge.
Yeah. I definitely miss observing. It's been way too long.
Yeah, and it I have to say we were actually talking before the broadcast went live. This winter has really been a stinker in terms of observing weather.
hmm Yeah, I remember
Um,
last year going crazy after like a month of not being able to observe, and this time around it's a lot worse.
yeah, and I don't know if we've gone a whole month with zero runs, but it was awfully close.
Oh yeah, yeah.
But yes, we're hoping for better weather in Toronto, which I guess is a take that for what with what you will. But of course, we do have wonderful archival images, and we are able to sometimes bring out our small telescopes, even when the big ones are in too delicate of a situation to allow us to open the roof. We have all kinds of stuff planned for today, and I will just go ahead and say that if you are tuning in for the first time this week, make sure to come back next week as well. We'll tell you in a little bit more when we get to reminders, but we're about to reach our 600th episode. That's right, this is episode 599. We've got lots of ups, lots of downs, lots of spacecraft to travel to. And I think what better way to get started with the 599th episode of York Universe than a little bit of space exploration in This Week in Space and Astronomy history. Sana, I think you have a great first item. Do you want to go ahead and go first?
Yeah, sure. So this one is a bit of a like double header, space and astronomy history, because it's they both happen on March 1st. They're both about exploring Venus, but they happen at very different years. So the first one is March 1st, 1966, which was when Venera 13 crash landed on the surface of Venus. And then a few years later, on March 1st, 1982, is when Venera 13 space probe actually took and returned the first color pictures of the surface of Venus to the Earth. So both of these missions were part of the Venera program, which was run by the Soviet Union in over 1961 to 1984, all about studying Venus. They sent a total of around 16 probes to Venus, which included a bunch of different things, including flybys, orbiters, and landers, as Venera 3 and Venera 13 were. Now, as is very common in like the earlier days of space exploration, the Venera program was kind of a mix of like successes and failures, and then like partial successes. The first couple of Venera probes didn't exactly go very well. There were also a bunch of other missions that the Soviets attempted to launch to Venus that weren't successful and never actually made it under the Venera probe mission series name. But their luck kind of started to change around Venera 3 in March 1st, 1966. Now, the original plan for the Venera 3 probe was that it was going to just enter the atmosphere of Venus and crash land on the surface. So they weren't trying to like do a soft landing where the probe could continue working after it landed. They just kind of wanted to send the probe through the atmosphere, collect some data, transmit that data on the Venus's atmosphere back to the Earth, and then just have the probe kind of crash land on the surface. Now, part of this did go according to plan because Venera 3 did actually enter the atmosphere of Venus and crash land on the surface. In doing so, it became the very first, human-made object to enter the atmosphere of another planet and then touch down on its surface. But unfortunately, there was some issues with some of its instruments when it was, impacting the atmosphere. And when it started to enter the atmosphere, some of the instruments got damaged. So they weren't able to actually collect any data or transmit that back to Earth. Still a pretty important milestone, I think, just because this was the first time that any human beings had sent a spacecraft to Venus or, another planet in the solar system and had it actually land on the surface. So still pretty significant. But if we fast forward a few years now to March 1st, 1982, it seems that the space program and the Venera missions had learned a lot from previous missions because the Soviet Union and the Venera program was now actually able to land landers on the surface of Venus and have them collect data and transmit them back to the Earth. There had been the Venera 9 and 10 missions, which had returned the very first images of the surface, but these were in black and white. So the Venera 13 mission became the very first space probe to land on the surface of Venus, do a soft landing with parachutes, continue functioning after that, and actually now return the very first color images of the surface of Venus. Now, all of the images from the Venera missions, or most of them at least, are all available online. They're actually really cool pictures, particularly the color ones. It kind of just looks like a really odd, honestly, I find it a little bit creepy sort of atmosphere on the surface of Venus. The pictures just have this very like yellow orangish kind of tint to them, which makes it look a little bit creepy and a little bit eerie, although that color specifically might not be the actual true color version of what the surface of Venus looks like. The thick atmosphere on Venus just tends to filter out blue light, so things might just look kind of yellowish orange just by default because of that. But the color images are still pretty cool nonetheless. And all of these pictures from Venera 13 and Venera 9 and 10 and later Venera 14 were able to just sort of paint this picture of the surface of Venus being very active. It had sort of what looked like active like lava flows and some volcanoes. And Venera 13 was actually even able to collect a sample of soil from the surface and analyze it on board while it was sitting on the surface of Venus, which actually did kind of give some information that was consistent with that active surface kind of idea, where it showed that the surface of Venus and the regolith that it analyzed had a lot of ash material, which included things like volcanic rocks. So it was a pretty interesting missions, Venera 13 and Venera 3. And I do want to point out one of the things that I find kind of most significant about these missions, particularly Venera 13, is just how crazy it is that you can actually make a lander to function on the surface of Venus. The landscape there is very, very different than other planets like Mars, which have like lighter and less intense atmospheres. And as hard as it is to actually get something to, do a soft landing on the surface of another planet, Venus has the added complication where its atmosphere is completely horrible. It's a very thick carbon dioxide atmosphere. So the surface has very high temperatures, very high pressures, can reach pressures of up to around 100 times the pressure that we experience at sea level on the surface of the Earth, and can actually reach temperatures of around like 500 degrees Celsius. So they literally had to make this lander that was able to actually not get cooked or baked or melted on the surface of Venus and continue working. Now, the Venera probes, like Venera 13, were actually designed to only work for around 30 minutes after touching down on the surface, but Venera 13 was able to outdo that, and it actually lasted closer to 2 hours. So it was able to return a lot of really cool data, 14 color images of the surface in total, and just do some really interesting science on the surface of Venus. So hopefully we can go back to Venus sometime soon. There has not been a lot of activity in terms of Venus exploration since around the 1960s, 1980s.
Yeah, exactly. And it's, as you say, it's this coming Saturday, but of course all the way back in 1966 and 82, we were, getting the best pictures of the surface of Venus that we've ever gotten.
Mhm.
Um, and it is incredible that they were able to do it. And you say that the pictures do look absolutely eerie and spooky, and I think they look just as poisonous as they are because it's, as you say, carbon dioxide, super compressed with sulfuric acid clouds and incredibly high temperatures, incredibly high pressures. I saw a back of the envelope calculation that showed that one standard human on the surface of Venus would be crushed to roughly the size of a tuna fish can.
Oh boy.
So, so if you really want an idea of just how hostile this surface is, it is astonishing that they were able to get anything sending back pictures from the surface of Venus. And one of the reasons why I think that there's been so little return to Venus is because people know now just how severe the surface is. They're like, oh, okay, so if we go there, we're just going to find acid and lava, I guess. But there are some missions planned, actually. There is I had heard of a mission that they were hoping to do in future called Da Vinci from the US and Envision from ESA, as well as potentially Veritas. But I'm not sure if any of those have are still on track. They're all uh, scheduled for 2030s, which is far enough in the future that awfully hard to say. Envision is just a an orbiter, um, and to think, with Venus, the really key thing would be to explore the atmosphere because there are regions of the atmosphere that have proven really interesting from satellites that people have been watching and saying, okay, well, maybe there might be some more we can do in the atmosphere itself without actually going all the way down to the surface where the conditions are much, much more hostile. Um, so hopefully some of those get to go out and explore Venus a little bit more. But yeah, it's a big change from I think this maybe more than any other planet was a real shock to people because when they first were imaging it, all we could see was that it had this beautiful blue color and thick clouds. And it's like, well, it was not a tropical paradise, which is what a lot of the science fiction writers were hoping for. Oh, it's a verdant jungle under there. It's like, nope.
Nope.
Uh, it is probably one of the most hostile locations in the entire solar system.
Mhm.
And all of that just goes to make, I think, your history item even more impressive because the Venera probes were, um, even if we do get these landers, I think they're still the only ones to actually get pictures from the surface.
I think so, yeah.
Um,
Just the
yeah,
Venera.
and it's no one else was foolish enough to try it. But I think, right now it's still a record breaker, the only surface pictures.
Hmm.
Um, and it's astonishing that this incredibly nearby Earth mass planet has so little exploration. But once you realize just how extreme it is on the surface, it's like you couldn't send the spacecraft you sent to Mars to Venus, it would be crushed.
Yeah.
Um,
Yeah, like
and
all
you
of this
certainly couldn't
effort.
put an ISS in there.
Yeah. Yeah, like there's so much effort around, sending the spacecraft there all for like half an hour of
Yeah.
data collection. So, if everything goes to plan.
Yeah, exactly. And so I think, a lot of people get distracted and say, okay, well, if it's that hostile, what are we looking for on the surface again?
Yeah. Yeah, at least Venus does look pretty in the evening sky.
Oh,
Um,
yes. And
so
of course, watching the phases of Venus is always something I recommend to anybody who has binoculars, because you can see the phases of Venus change in a similar but different way to the phases of the moon.
mhm.
Very, very fun stuff. And yeah, I think there's a lot more to be done on Venus, but it remains to be seen if we'll get to see it or not.
Yeah, would be nice, but
Agreed.
yeah.
Would be even better if there were tropical jungles, but that's a discussion for our, I don't know, upcoming sci-fi episode of what's gonna. Um, all right, so I've got a similar sort of exploration. I was looking for interesting, fun things from this week, and it turns out that tomorrow, February 25th, but back in 1969, so in a similar-ish era, we had a very interesting spacecraft called Mariner. And Mariner was actually part of the Mariner program, and the Mariner 6 and 7 were kind of launched together, so to speak. But it was a really, really interesting. So February 25th, 1969, the Mariner 6 actually launched itself up. And so, Mariner 6 was one of the, I suppose, really key missions for exploring Mars. And it was part of the sort of dual spacecraft mission of Mariner 6 and 7. So the sixth one was launched on the 25th, which is tomorrow, back in 1969. And of course, they were flying by Mars to get some of the first ever pictures of Mars and its atmosphere. And they wanted to find out about the surface of Mars. And, of course, there was a lot of science fiction around Mars at that time as well about, potentially were there really canals, that kind of thing. Find out what kind of basis for future investigations might be uncovered. Would there be extraterrestrial life, which is always a question when you talk about Mars, even today. And what kind of technology would we need to actually explore Mars? So it wasn't really known at that time how other explorations might be carried out, because in 1967 we didn't have a lot of very detailed data because we only had, of course, ground-based pictures from Earth, which were not very detailed. So of course we had these cameras coming out with the spacecraft. Each Mariner 6 and 7 both had wide and narrow angle cameras, but not cameras like you're thinking cameras, not cameras like your phone. They had television cameras, infrared spectroscopes, an infrared radiometer, and an ultraviolet spectroscope. They were collecting data in a very different way than we might do so today. Both 6 and 7 of Mariner spacecrafts were pretty much identically constructed, and the Mariner 6 was launched from the Launch Complex 36B at Cape Kennedy, like I said, on the 25th of February. And then Mariner 7 was launched 31 days later. This was the first mission launched on the Atlas Centaur spacecraft, just as a little FYI. And this is one of the early launching systems that had a half-stage Atlas SLV-3C and then a restartable Centaur stage. Very different from what you might have seen if you've been watching the most recent Blue Origin or SpaceX launches. It still jettisoned their boosters, which were not retrievable, and of course, Mariner 6 had deployable solar panels, and then it corrected its course on its way to its Mars flyby. Um, there was a little bit of a drama, I suppose, early on in the mission when Mariner 6 had a mid-course correction. A few days later, there were explosive valves deployed, which actually were supposed to unlatch the scanning platform on the spacecraft, and some bright particles actually got released during this sort of unlatch, and they lost their attitude signal on the spacecraft. And so they basically had to put it on what's called inertial guidance to for the Mars flyby to make sure they kept a good contact with it, basically. It was a really, really interesting area of exploration and a really interesting time because, as they were approaching Mars, they were trying to scan the planetary surface with their imaging devices and return as much data as possible. The closest approach was at about 3,431 kilometers from the Martian surface, so not so close that they would get pulled in by Mars's gravity. And after its closest approach, Mariner 6 passed behind Mars, swung around, and reappeared after 25 minutes. So you can imagine just how much kind of nail biting would have happened in that 25 minutes when they had no signal at all from Mariner 6. It was a really, really interesting, sort of moment in history using these sort of TV display to return the signal and give the data back to dishes here on Earth. I think the Canberra DSN was still in use, but I'm actually not sure which dish was receiving the signal from Mariner 6. I'll have to look that up later, or put it as a question for chat if people want to talk about it. So Mariner 6 was really, really interesting, and of course, it did return some of these very first images of Mars. They showed that Mars was very, very different from the moon. And it had some contrast to Mariner 4, which had been, by all accounts, fairly depressing and just showing a very dry, dead landscape on very low resolution. But Mariner 6 and 7 had, quite a few extra imaging and extra resolution in compared to earlier missions. So close-ups from the near encounter covered about 20% of Mars, which doesn't sound like a lot, but it was pretty good for that time. They were able to measure atmospheric surface pressure. They got better measurements of mass, radius, and shape, all for Mars. And they were able to return, and this is true, 800 million bits of information. That's right. And this is Mariner 6 and 7. The total data from both missions for their flybys returned was 800 million bits. And this is a really kind of fun stat because Mariner 6 had 49 far encounters and 26 near encounter images of Mars. Mariner 7 had 93 far encounter images and 33 near encounter images. And altogether, with 800 million bits of information, that's only 100 megabytes, or as we measure in computer sizes today, 0.1 gigabyte. That's the equivalent of one large photo or one very small video on your phone today. So that was the entire data return from both spacecrafts, which was revolutionary at the time. Now, Mariner 6 continued on after its flyby, but we did not keep getting access to it. We don't exactly know its position right now. It's a little bit of a mystery. So it's out there floating in space somewhere between 1.14 and 1.75 AU. As a reminder, the Earth to the Sun is 1 AU. NASA kept getting data from Mariner 6 until about mid 1971, and I couldn't find any traces of signals after that. But it should still be out there in that general region should human explorers ever get good enough at space travel to go and find it. So I hope everyone has a happy thought for Mariner 6 stuck out there in space, but giving us lots of beautiful Mars images before it did get stuck.
It's kind of crazy to think about like all the cool stuff you can discover with like 100 MB.
Yeah, and
Like,
that's every single bit counts, right?
yeah.
It's when you think of the amazing capacity we have now, there's a good reason why James Webb Space Telescope is returning such groundbreaking results in so many areas. It's the I don't know, it's not necessarily the Mariner 6 of its time, but it's it's on that cutting edge, just like Mariner 6 and 7 were back in 1969.
Yeah. Yeah, it's funny that you mentioned JWST because when you said that 100 MB number, my first thought was that some images from JWST that I've downloaded are like 2 GB in size.
Yeah,
So
yeah.
like single
So
image.
0.1 of
Yeah.
half of a 2 GB image is all the bits that Mariner 6 and 7 were able to return with their TV broadcast images from Mars.
Yeah, why TV broadcast? That's an interesting choice. Um,
Um, yeah, I'd have to look up. So the TV broadcast, it's not like a TV like the TV that were in the houses at the time. It was the two TV cameras were on the scan platform taking the photographs, and then the antenna that was returning the signal was a little bit different than what like a standard TV broadcast signal would have been.
oh, okay. So not just simple
Yeah, not simple TV cameras, but it is still a TV camera type camera.
stuck to
So
a spacecraft.
not, yeah, exactly. And there are some great pictures actually of the design schematics that people can go and look up on the NASA Mariner 6 site. So if you're really keen to just see some of the old cool equipment, they've got very good schematics on both of them because they were twins.
Yeah, with a few other spacecraft were twins too. It's interesting how they launched a bunch of the twin spacecrafts, but
Yeah, it doubled your chance of success, I suppose.
yeah. Yeah, like Venera 3 and 4 I think were both twin spacecrafts or Venera 13 and 14 were twins, but
Yeah.
anyways.
Well, speaking of spacecrafts and interesting things, it looks like we can get to your next item.
Ah, yeah. So this is another interesting launch, March 2nd, 2004, which was when the Rosetta mission launched. Now, the Rosetta spacecraft, it was actually a two components, the Rosetta orbiter and the Philae lander. It's a mission run by the European Space Agency to Comet 67P. Now, it has a longer name. I'm not even going to try and say it because I will butcher that completely. But this was a really new kind of mission that had never been attempted before, which was to send an orbiter and a lander to get the first really up close observations of a comet. So, a really cool idea to actually put something in orbit around Comet 67P, which was the Rosetta orbiter, and then have a lander called Philae land on 67P to be able to kind of analyze do actual analysis of the surface of the lander, while Rosetta could study more like the the environment of the comet and how, as the comet approaches the sun, how that changing environment where it's encountering, more intense solar radiation and actually interacting with the solar wind can change the comet and kind of cause it to evolve. Now, the pair, not exactly twin spacecraft, but I guess sibling spacecraft in a way, launched on March 2nd, 2004 from French Guiana. As with many, many other of ESA missions, they launched on the wonderful Ariane 5 rocket, which brought us JWST and tons of other cool space missions. They spent the next around 10 years sort of traveling to Comet 67P, and they ended up doing quite a bit of a dance in sort of the inner solar system when they were on the way out to the comet. They ended up doing four gravitational assists or gravitational slingshots, one from Mars and then three from Earth, which produced a lot of, really cool data and pictures as it did these flybys, particularly of Mars. There are a couple really cool shots of the spacecraft in front of Mars that it kind of took with one of its cameras. But when it finally did reach Comet 67P in August 2014, it was put into a nearly circular orbit around the comet, orbiting, I think, an altitude of around 30 kilometers, so actually very up close, and became the first object that was ever put into orbit around a comet, or the first man-made object at least. The first couple weeks of Rosetta's mission was pretty much just surveying the comet. This was, of course, partly for science and starting to learn about the shape of the comet and get the first up-close pictures of the comet. Rosetta revealed it to be a kind of duck-shaped comet. It had these two lobes that were sort of stuck together. One of them was sort of like round and circular, which worked as the head of the duck, and then the other as the body of the duck, which was sort of longer and more elongated, so kind of rubber duck shaped shape to this comet, which was pretty cool. But the other reason it was doing so much surveying at first is just because it needed to find a landing site for the Philae lander. So there were a couple of different criteria that ESA needed to be a good landing spot for Philae. With one very important criteria being the area had to have sunlight so that the lander could actually, function properly. It could use the sunlight to power its batteries and not freeze. So the area that it landed in, very importantly, needed to be get a lot of sunlight and not be one of these cold, dark, shaded regions of the comet, which there were several of those regions kind of kicking around in there. So the Rosetta orbiter did eventually find a landing site that was later named Agilkia. I think I'm pronouncing that correctly. And eventually, in November 12th, 2014, the Philae lander sort of detached from the Rosetta spacecraft and attempted a landing on the surface. Now, it did successfully land on the surface of Comet 67P, but unfortunately, it didn't land where they wanted it to. The lander was equipped with several harpoons that were supposed to sort of trigger when the probe hit the surface and then latch onto the surface of the comet so that it wouldn't bounce off of the comet and it would actually stay where they wanted it to. But unfortunately, those harpoons didn't deploy. So it touched down where they wanted it to, but instead of just staying there, it actually bounced off the surface not once, but twice until it eventually, came to rest in one area of the comet. Now, remarkably, it actually survived this like bouncing off the surface and landing three times on the surface of the comet. But unfortunately, it landed in one of these very shaded regions on the surface of Comet 67P. So it wasn't able to last for anywhere near as long as the mission had originally planned to last. And it only got 3 days of science in before it turned off. Nonetheless, I think you can still count this as a bit of a mission success because they did, successfully land this thing on the surface of a comet. And while Philae was, functioning in those 3 days that it was on the surface, it was able to do quite a bit of science. It took some pictures, I think even a video of the surface of the comet, and also analyzed some of the composition of the comet's surface, where it found some organic molecules, most interestingly. Um, it is also kind of cool to note that the Philae lander did wake up a few times in July 2015. The comet had just gotten closer to the sun by that point, and different areas of the comet were getting hit with little bits of sunlight. So, over a several week period in July 2015, the Philae lander did get enough sunlight that it could turn on and sort of start communicating with the Earth again, but I don't think much of anything really came of that. And it did permanently go to sleep after around July 2015. The Rosetta orbiter, on the other hand, continued working for around 2 years in total before it was purposely crashed into the surface of Comet 67P on September 30th, 2016. Now, there were a whole bunch of interesting discoveries that came out of this mission, which includes, but is definitely not limited to, discovering several important organic molecules and compounds in on the surface of the comet. This included things like amino acids and phosphorus, some of which can be important, building blocks for DNA. It also discovered how the shape of a comet influences the seasons on the comet and how the comet is sort of influenced by its environment. So things like, the solar wind and how dust moves around the comet can be influenced by the shape of the comet itself. And the orbiter and lander, they also discovered evidence of molecular oxygen and nitrogen in Comet 67P, which can be important for understanding the way that the Earth got its massive oceans and massive amounts of water. So it was a very interesting mission in total. And yeah, I think definitely one of the cooler space missions.
Oh yeah, absolutely. Literally and figuratively cool.
Yeah.
And of course, if anyone hasn't had a chance to look up some of those images of 67P from Philae and from Rosetta, they are astonishing. Like
Oh,
just
yeah.
the landscapes are, as they say, truth is stranger than fiction. The landscapes are stranger than anything you could imagine. And that
Yeah.
just makes them, it just makes them wonderful. And of course, there is the video as well. Like you say, the little video clip they were able to put together of the detailed surface from Rosetta. And this mission has, you know, so many wonderful aspects to it. As you say, like they did end up crashing. I mean, I would argue maybe they kind of crashed twice because the lander, they like to say that it bounced, but
Yeah,
you know,
crash.
yeah, it was pretty much crashed. But they discovered so many interesting things along the way. I would hesitate to ask how much data they managed to send back because it would have been a lot more than 100 megabytes.
Mhm.
Um, and of course, we learned a lot from it because the harpoons didn't work. If we do get another comet chaser, maybe we'll have a little more luck getting it to getting something on the surface to do tests.
Hmm. Yeah, some of the you mentioned the images before, and one of the really cool things is that like you can see at certain angles like the comet is almost like backlit by the sun, so you can really see like the streams of material that's just flying off of the comet. But yeah, those pictures are stunning. They're so pretty.
Oh yeah, there was one in particular. I think it was one that Philae took and managed to send back, looking up at one of the mountains of
Hmm.
mountainous ridges, I guess I would call ragged cliffs. And it's just so so cool because they're such different shapes than any kinds of cliffs could ever be on Earth.
Yeah.
And of course, they have to be. It's a very low gravity environment. It's this extreme, strange place that's in the process of being, semi-evaporated by the sun. But yeah, it's once you zoom in, the duck kind of looks more like an angry duck because it's all pitted and cratered, and then the real surface images show that it's got these really extreme, sharp-edged cliffs and features.
Hmm. Yeah, stuff is just I don't know. Everything in space is just so pretty. It doesn't matter what it is.
And it's also a good argument for spacecraft because even Hubble could not have picked out any of these details. And the Hubble pictures before the mission came, they had estimates of it looking kind of like a wobbly star or like a blobby um, sort of triangle-y, pointy shape. And
Hmm.
it's like that was the best they could do with Hubble because they had no resolution. It's just sometimes you just got to go there.
Yeah. Yep, that's always the
Um,
best.
exactly. Well, I think we're about at the halfway point, so let me go ahead and just do the reminder so I don't forget. Everyone, you're listening to York Universe. We're broadcasting live from the icy and snowy Allan Carswell Observatory, not maybe as icy as a comet, but still pretty cold, located at York University in Toronto, Ontario, Canada. Our website is yorku.ca/science/observatory if you're looking for any of our recorded content, our archives, or if you want to join us for live tours. Tonight, you're listening to Sana Withers and Dr. Elena Hyde, and we're discussing, I guess, things that have launched and crashed, um, or accidentally or otherwise. And if anyone has any questions or comments, please do join us live on OPV for the live broadcast and ask them directly in YouTube. Otherwise, of course, you can see that same website and check out all of the wonderful recordings. All right, so that's our little reminder for everyone. Now I've got one more little this week in space and astronomy history, and then we've got some reminders actually for the observatory and some news items. So I have one more little history event that I'm going to sneak in here. It's not so far back as some of the other ones. So this is more 2009, 1 March. So that would be Saturday. Back in 2009, we had another thing that actually crashed, but on purpose, we swear. This was Chang'e 1, a lunar orbiter. And March 1st, 2009, we got to see Chang'e 1 crash intentionally on purpose into the moon. So Chang'e 1, if you haven't heard about it, it was launched on the 24th of October 2007. And of course, this is part of the Chinese space program, and this is the first phase of their lunar exploration program, which has done a lot of really good stuff. The first picture of the moon was relayed back from Chang'e 1 on 2007 in November, and they used Chang'e 1 to create a map of the entire lunar surface, which was released. This was all launched from China and part of their, as I say, part of their satellite and exploration program, and in particular the Moon program. I actually thought it was interesting when I looked up the launch center for this one. It was launched from Sichuan province at a new space center, Xichang, that seems to be pretty quite recent. This is a uh, part of the Sichuan province of China, and I was really interested to see that they've got this extra launch facility. Really, it looks like just for these launches. Their Long March 2E carrier rocket, which was also used to send Pakistan's first indigenously developed satellite into orbit, which is just kind of a cool, interesting thing. And I hadn't read as much about the Long March carrier rocket design. To me, it seems kind of similar to the Arianes, but I'm not a rocket expert, so that's as much as I'll say about that one. But Chang'e 1 was a great success by all accounts. The data gathered created a wonderfully accurate 3D map of the lunar surface. And this was the first lunar probe that actually conducted passive multi-channel microwave remote sensing. And they used a microwave radiometer. So we're talking about strange technology being used. This is even more interesting than I think using a TV screen. This was not the end of the program by any means, because the sister probe Chang'e 2 was launched in 2010, just a few years later. So the lunar exploration program that Chang'e 1 was the start of was designed to be conducted in 4 phases. So Chang'e 2 was in 2010, Chang'e 3 in 2013, and Chang'e 4 in 2019. And of course, Chang'e 3 was the lunar sample mission, and of course, and we've now seen a lot about water, actual water deposits in some of the icier regions of the moon. So um, that being able to map some of these elements has just been really, really interesting because the parts of the moon's craters that never get sunlight, no matter what the phase of the moon is, means that when water is deposited from collisions with comets or other things that have water on them, they don't get evaporated by the sun. So on the lunar surface, anywhere the sun hits, water can evaporate and it's not going to stay there. The moon has no atmosphere. Um, so it's really quite interesting that these craters have geometry that means that the sun never hits them and that they actually do seem to have water ice in some of them. So the elements studied so far have mapped all kinds of interesting abundances. In particular, of course, water, but also helium-3, which is a stable isotope of helium, which is one of the, I suppose, future fuels that people keep talking about. They're planning to expand the elements studied to include things like silicon, magnesium, aluminum, and other things as well. So just a really, really fun program. But of course, it had to end sometime, and they decided to end it spectacularly by crashing. And this is it's not called crashing if you do it on purpose. It's a controlled impact or a planned deorbit, which is sounds a lot better than crashing. Um, I did actually look up how much data the mission managed to transmit before it crashed. This mission, Chang'e 1, sent back 175 gigabytes of data. And just as a reminder, the other one was zero point 0.1 gigabytes. So that's the difference that quite a few years can make in terms of the amount of data you can send back. When it crashed on the lunar surface, they were of course able to watch it go down, and its impact point is actually on the wiki map of the moon. So you can actually play spot the impact if you've got a really, really, really large telescope, or if you plan on I don't know going to the moon and visiting it someday. But it's been, one of the really fun missions to watch, of course, with the Chinese lunar exploration and the uptick in lunar exploration in general. I am still a little bit wondering how the Artemis mission is going to go, if we're going to get more delays or if they really are going to launch next year.
Yeah, I really do hope Artemis launches next year. It's
I hope so too.
it's really awesome that there's gonna be like a Canadian on board one of the Artemis missions. I knew Canada had been involved, but I didn't realize that Canada was gonna get a seat on the Artemis mission so soon.
Yeah, yeah, and of course this would be the flyby. They're not landing, but it's still really, really exciting. And of course, there's plans for Lunar Gateway, and we can only hope that all of any crashes involved will be intentional ones.
Yeah. Yeah, the moon is, I think it's got to be like my favorite object to observe just because it's so close. You can see everything in such detail. So definitely excited for the moon missions.
Absolutely. And speaking of, I suppose, things in the sky, there's a little bit of a couple extra reminders. Do you want to give the Saturn reminder?
Sure. So if anybody's looking to do observing in the early evening, if you go outside about 30 minutes after sunset, probably just in the next few days, you'll get a chance to catch Saturn and Mercury being pretty close together. So they were actually at in conjunction today, separated by only about 1.5 degrees, but they should still be remaining, pretty close in the sky over the next few days. This is a bit of a tricky one to observe because Saturn and Mercury are both very close to the sun from our perspective at the moment. So you have to go out like just after sunset. I think the recommended is about 30 minutes and make sure to have a clear view of like the western southwest horizon. So just like, definitely not in Toronto where there's just buildings and everywhere in the way. But if you can manage to get like a view of the lower part of the horizon, and you have a pair of binoculars, you can definitely see Saturn and Mercury kicking around in the sky together. Mercury will be very easy to see just because it's very bright, but Saturn, not so much. So this might be a little bit of a tricky one, but definitely something cool to observe if you're looking to observe in the early evening. All we
Yeah,
need
and
is
this will,
guys.
yeah, exactly. Um, this is a great time to go out and look uppity, as you say, Sana.
Yeah.
This is, and the Saturn, I will just say, this is pretty much your last chance to try to view Saturn before it gets too close to the sun, and you definitely should, because if you can get a picture of Saturn now, it will have its rings at almost its thinnest possible point. So Saturn's rings are in the process of disappearing. Ooh, so we'll talk more about that next time. But this coming week is pretty much your last chance to try to get a picture of it or see it before it gets so close to the sun that you're just not going to be able to view it safely.
Mhm. Yeah. So no more 1 meter observing of Saturn for the next couple weeks, I guess.
Well, unless we can get it tomorrow.
Yeah.
So if we can get it tomorrow, we'll definitely get that picture and post it on all of our accounts.
Yeah.
That's the promise. All right, so let's go ahead and look at some fun news items. So we've had a lot of purposeful crashes in this episode so far. But how about a crash that's not going to happen? I think your news item would be great to start with.
Yeah, yeah, this would be it's definitely very good news. So for anybody that's been following the news on the possible asteroid impact YR4, will definitely be happy to hear this news item. Now, this is an asteroid that has been getting quite a bit of media attention recently because it's a fairly big asteroid. It has a diameter of about, I think, 50 meters or so. And over the past few weeks, studying its orbit has kind of shown that in 2032 there was a potential impact risk with the Earth. That number has been jumping around a lot, from around 1 to 3% chance, which is still pretty low. But for asteroids, that 3% chance of impacting the Earth is actually pretty high for an asteroid of that size. So it has been getting quite a bit of media attention and has caused a bit of a panic for some people. It was even dubbed the city killer asteroid, by I don't know who, but that's a definitely an interesting name
No.
for it. Yeah. But it turns out, as quite a few astronomers had already suspected, that everything is fine. It's not going to impact the Earth in 2032 like some people were believing. The long story short of this is that there were just updated measurements on its path and its orbit around the sun. That initially the measurements weren't very good. The uncertainties were pretty high, so the percent of chance that it could impact the Earth was kind of climbing up to 2-3%. But the JPL Center for Near Earth Object Studies recently updated that number and lowered it from 3% all the way to 0.005% for that 2032 impact. So if anybody had been worrying about YR4, killing a city and impacting the Earth, there's really no need to worry. This was something that had been pretty expected by astronomers. Again, I know a lot of people had been panicking about it, but happily turns out that everything is okay. It is still going to do a relatively close pass to the Earth in 2028 and then again in 2032. In 2032 specifically, it should be coming within around 170,000 miles of the Earth, which is actually closer than the moon by around 100,000 miles. So it is getting pretty close to us. It'll be a great opportunity to be able to study the asteroid a little bit more up close. But again, this is really not a threat. This is not something to be worried about because asteroids getting this close to Earth is actually very common, even for asteroids the size of YR4. Yeah, that was the condensed version because we are running a bit short on time, but definitely good news for anyone who had been worried about this.
Oh yeah, and as you say, the it this is around about closest approach is around about at 100,000 miles closer than the moon, but
Mhm.
the moon is still over 200,000 miles away.
Yeah. Yeah, like I
So
think
it's
it
still gonna be quite far. But it will be actually an excellent one to try to catch with your telescope, because this is your good chance to maybe actually get a picture that's bigger than 1 pixel of an asteroid.
yeah. Yeah, so it'll still be fun for the asteroid to pass by, but not worrying.
It'll be a lot more fun, actually. It's gone from worrying to a really good time,
Yeah.
where we can watch it go by and it won't come in and hit us, but it will be a good thing to try to catch with your telescopes.
Mhm.
It will probably need a fairly large telescope to see. I forget what yeah, 50 meters. Yeah, that doesn't. You're going to need a large telescope to see
Yeah.
it. But at that distance, it will be visible as a thing, maybe 3 or 4 pixels, depending on the size of your telescope.
Yeah. Just need like 3 or 4 days back to back with clear skies and you can just sort of chart it as it moves through the field of view. That'd be cool.
Or we use one of these rockets and we go launch something.
Yeah, it's gonna be so close to us. It'll be so easy
I
to
know.
get. Yeah.
Yeah, it's gonna actually just super easy. We just need, Blue Origin or SpaceX to give us a ride, and we're good to go. All right. So I've got one more teensy tiny story on a crash, because I thought I could just dump it in here at the end where so this was also in the news. Speaking of things that are much, much more likely to hit the Earth, this is a little bit of an interesting one in Canada, and I mean just in Saskatchewan in particular, but it's been in the news quite a lot that certain things have been coming from low Earth orbit and impacting the Earth. This is the rocket debris. Um, and space junk debris. So asteroids might not be a problem. This one that you mentioned certainly won't be, Sana. But what is much, much more likely to hit us is, at the moment, SpaceX debris, because a lot of it has been coming down. Blue Origin debris also came down a little bit ago, but the news article I'm going to use for my little item today is yet another fairly large chunk of SpaceX rocket debris has come down, this time landing on a fellow's lawn in Poland. So this is a what they call uncontrolled re-entry into the atmosphere, which has been causing debris to fall all kinds of places because they're not tracking where it will land. They're just letting it come back into the atmosphere and land wherever it wants. So in this case, on February 19th, the uncontrolled entry into the atmosphere of a Falcon 9 reusable launch vehicle over Polish territory resulted in a big, big piece of junk landing on someone's lawn. Um, the mystery object, they were calling it, was quoted as being resembling a tank, so fairly large, crash landed into the lawn of a fellow named Adam Borucki's warehouse in I have to say this right, Komorniki, Poland. But yeah, very, very, unsurprising. They found an identical container about 30 kilometers or 19 miles away. And the part of the rocket which um, that fell was a fairly large piece, which is also what we saw when some of the material came down in Saskatchewan here in Canada. The debris that landed in particular was about 1.5 meter by 1 meter wide, which is a pretty large hunk of metal traveling at reentry speeds coming back in. So it was, potentially, if it had hit the house or their workshop, they would have had a pretty big problem. They've had pieces of rings crashing all over, and in 2021, we had, of course, um, the Chinese rocket falling down as well. So it's one of those things that we're seeing happen more and more, and in the news now. It's just happened over in Poland. So if you really want to worry about something landing on Earth, I would say your statistical chances are much more likely to happen from space debris than from the asteroid.
Yeah, that's definitely a little bit worrying.
Yeah,
That,
that one we can actually get worried about.
yeah.
It's not going to destroy a city, but it could put a hole through your house and your second floor and your first floor, like what happened in Florida. So
Just waiting for the first lawsuit to come out of this. I guess we'll be talking about that in a future episode of York Universe.
yes, yes. If they post what happened with the house one, we'll definitely cover that in a future episode.
Yeah.
All right, so we've had launches, we've had crashes, and it's probably about time to wrap up for this evening. So, everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by students, faculty, alumni, and friends of York University. The hosts this evening have been Sana Withers and myself, Dr. Elena Hyde. Just as a little FYI, you can always find more about York Universe or the Allan Carswell Observatory over on our website, yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies, everyone, and have a good night.